This episode is supported by MonsterJoysticks.com. Level up your Raspberry Pi with our all-in-one arcade kit using genuine Sanwa arcade parts. And OneClickPrint.com for your photos on canvas, acrylic, gifts and more. Local craftsmen and global delivery.
Hello Cave Dwellers, it's a new year and what better way to start the year than with a new Trash to Treasure. And we're doing it a bit differently today. I've got a guest with me, it's Mark from Mark Fixes Stuff. We've seen him in the cave before. You came with your ZX Spectrum items before, didn't you?
Heaven and Hell.
Heaven and Hell, ZX Spectrum Heaven and Hell. And we're going to put Mark to the test today. Is he up to his namesake, Mark Fixes Stuff? And we're going to learn all about this, the Pioneer LaserActive. It's I had it shipped over from Japan. It's in a non-working state, and we're going to find out all about it and hopefully, with Mark's assistance, get it working. Mark, have you ever worked on one of these before?
Nope, never seen one before in my life, but it's just a big sort of CD player really, so if anything it should be easier if you think about it.
It's just a big CD player. That fills me with confidence. Well, let's get familiar with it, Mark. While we're doing that and getting our tools ready to crack on and try and fix this, I'm going to give you a history lesson now on the Pioneer LaserActive and we can learn a little bit more about the system.
So what exactly is this then? The Pioneer LaserActive or CLD A100 provided entertainment for the wealthy with a retail price of $970 or 89,800 yen on its release in North America and Japan in 1993. That's about $1,700 allowing for inflation at the time of this video. And that was just the base price because this is a modular converged device. Alone it plays laserdiscs and music CDs, which is nice, but there were much cheaper options available for that functionality at the time. But drop around $600 or $1,000 in today's money on an add-on pack module such as this, the Pack S1 or Mega LD pack, and you can now play Sega Megadrive cartridges, Mega CD games and Mega LD games. That's Megadrive games such as this, Pyramid Patrol, which was bundled with the pack. Megadrive games on Laserdisc. Now that's pretty cool. Around 20 such Mega LD titles were released, and there are unreleased prototypes such as Myst, which sadly didn't make it to market. But we're not done here yet. Drop another $600 on the Pack N1 module and you now have a fully functioning PC Engine with support for PC Engine CD-ROM titles and PC Engine Laserdisc titles. If you've still got more cash burning a hole in your pocket, then it's time to buy the Karaoke pack at $350, offering 2 microphone inputs with individual volume controls. Load up your music CD or laser karaoke title and you can impress your friends with your singing skills. Sadly, I don't have the karaoke pack to demonstrate, but that's probably for the best. There's also a computer interface pack or Pack PC1 which provided an RS-232 port and enabled the LaserActive to be controlled by software you've developed on your PC or Mac. And finally the GOL1 or LaserActive 3D Goggles pack, which allowed you to use active shutter glasses to watch an extremely limited range of 3D Laserdisc titles. So this all makes for a fun curio, but I'm sure you've already guessed by now that at these retail prices it was not a commercial success. Around 10,000 units were made. The intention was for the LaserActive to be a competitor to the new 3DO and CDI consoles on the market, and no doubt a CDI or 3DO module could have been squeezed into an add-on pack if partnerships were forged. But these competing consoles were also unsuccessful, of course, because what the world was really holding its breath for was an affordable, so that ruled out the 3DO, and truly next-generation 3D gaming system, so that ruled out the CDI, Megadrive and PC Engine. In the following year, 1994, that would be delivered in the Sony PlayStation and Sega Saturn. The Pioneer LaserActive was discontinued in 1996, and its place in history remains a footnote of tech opulence reserved for the wealthy. A crash course for you there in just what this is, and I hope to show you a lot more of this system in action, but first the task at hand, we've got to get it working. The movie Twister was an added bonus trapped in the drive here, and if we're to make progress we need to get both the disc and the drive tray out of the way to make components accessible.
I want to take the disc out because it will get in the way of anything we're doing. Now this is probably a dual mechanism, which means that it will have a smaller mechanism for small discs and a larger mechanism that will sort of like work in addition. Oh, that come out now? Don't want to damage the disc as soon as it's a bonus.
It looks pretty scratched up already, but there we go.
As Mark and I got familiar with the device and worked out how to tackle it, I should make you aware of the reputation the LaserActive has. This machine is known to have been built with terrible capacitors. Every example you find is pretty much guaranteed to have leaking caps on some or all of the 4 main PCBs within. Anticipating this, we chose to work from the power supply unit board backwards. That's located under the tray, and it's what we're aiming to access here.
What you usually find is with any tray loading mechanism is when the tray goes in, a mechanism will come up, clamp the disc, and what that does is disengages the tray,
right,
or locks the tray in position. So this mechanism being up is stopping this tray moving. Now,
right,
what we need to find is the pulley, belt or gear that reverses that tray to drop it down. Now I can see there's a pulley just under here, which might well be the one.
Drive tray safely out of the way, we now have fairly easy access to the PSU board on the right side of the picture here. 3 cables send ground, 5 volts, negative 5 volts, 14 and negative 14 volts out to the other boards. So this is a good place to start because of course power is essential to those boards operating.
So with power supplies, one of the things that kills them is capacitors are basically a can full of fluid in sort of very layperson's terms. And these things here are called heat sinks. They sink the heat away from components.
Right.
Doing quite a lot of work. Now, if you take something full of fluid and then you put it next to something hot, over time what happens is it will dry out. So the main suspects within a PSU are usually the ones that are nearest the heat sink.
Common problem you've mentioned in the past with the 3DO. It's got
Yes.
a cap right next to a big old heatsink.
Literally boils it to death.
Yeah.
And the smaller the cap, the more prone they are to dry out. So I think the best course of action with this would be just to recap the whole lot.
Okay.
Yeah.
And we'll test them as we go and
Yes.
just see which
if
is
we
the
found the
culprit.
right one. You pull all the teeth out and see if you found the rotten one afterwards.
Right.
Pulling out all of the teeth to find the rotten ones. Sounds like fine British dentistry to me. Armed with the vacuum desoldering gun, we were able to make short work of removing the old caps, and we tested them as we pulled them out. But it quickly became obvious that nearly every cap we removed was in fact a rotten tooth.
Yeah. Oh no, the ESR's massive. Look. That's huge for a cap that size. Absolutely huge.
So that one, you can see just around the leg there's a bit of gunk around it as well.
Yeah, but because sometimes it's the potting. Yeah, that's leaked.
Yeah.
Definitely leaked.
With such obvious visual clues as crusty electrolytic fluid around the component legs, there really wasn't a need to use the tester anymore. And it wasn't just on the caps. If you look closely here, you can see small puddles of fluid underneath where the capacitors have been removed. The electrolytic fluid is alkaline in its nature, so we neutralised it with an acid, in this case some white wine vinegar, on the end of the cotton bud. And then we cleaned the area with some isopropyl alcohol to stop either the electrolytic fluid or the vinegar from damaging the board. As far as damage went though, yes, we had leaks, but visually we couldn't see any corrosion on the board, and that was a promising sign. And as if further evidence was needed, just look at these. These capacitors are very unhappy. They didn't display signs of bulging on the tops of them, but as soon as you look at the underside, it's obvious they're only good for the dustbin. And so, on to the task of fitting new capacitors to the PSU board, which of course we performed with huge optimism, having seen the state of those old caps, confident that we'd soon have this fixed. Just call me the dentist.
We've got the caps on the table there, Mark. A lot of evidence of leakage.
Yeah, lots of electrolytic leakage. Yeah. We also found that the board was wet, didn't we, as we saw earlier. And that's something that happens quite a lot when you have a vintage machine that's taken out of storage and then powered on. What happens is the seals inside the capacitors can shrink, and then the extra work that's applied to the aged capacitor will cause it to leak. So it's quite important to get that fluid off of the board as soon as possible because it can cause damage.
Cross your fingers, cross everything. I'm going to press the power button.
This is genuine as well, not faked.
It is genuinely the first time we've tried turning it on. So I'm going to reach around and turn it on. 3, 2, 1. We have power light. Press the drive tray. No!
No!
Let's just try the other video output. No, there's nothing.
Nothing, tra-la-la. So we need to...
Well, we've got a nicely recapped PSU board.
Now we need to look further for the fault.
Yeah, curious. Okay, we're going to scratch our heads for a bit now and see if we can find out what the problem is.
Not so confident now, are we? What we could see is that we're getting all of the correct voltages from the PSU, so we can now avert our attention away from that board. The main boards we need to investigate further then are the RGBB assembly, which we're poking here, and that includes the TV signal encoder. In this case that's an NTSC signal. The green video board on the left has a forest of capacitors on it, and such things as the video processor, audio demodulator, video memory, etc. Hidden down at the bottom is the INTF board, which I think likely stands for interface, but please correct me if I'm wrong. On here is an NEC microprocessor and a 16-bit digital audio converter, among other things. This is also the board the add-on packs slot into when inserted and interface with the rest of the system. And surprise, surprise, it's this very board, the least accessible, which we've spotted a problem on, and now we need to aim for it. And you can likely guess what the problem is. I know Mark and I are certainly now understanding why the LaserActive has such a bad reputation for capacitors.
Mark, you've got a little bit obsessed in there. You've gone down the rabbit hole, haven't you?
Yes, smell the prey. So, I mean, obviously we had an unsuccessful turn on.
And it's quite obvious why now, isn't it? It's not pretty.
It's not pretty. So what we did, we checked the voltages coming out of the power supply into the board. Now you've got a couple of sets of voltages here. You've got plus 14 volts, minus 14 volts, plus 5, minus 5, and obviously ground. And they all check out.
Yep.
Coming into all the points.
They were spot on, weren't they?
They're spot on. So we can ascertain that the PSU is doing its job.
And that wasn't time wasted. Clearly it needed to be done, so we've got a good PSU board, but that's just about the only good board that we've got in here now that we've looked closer.
Because as you can see, this capacitor down here has leaked. And it's all over the tip of my finger. So And we can't quite get to this board without taking all the other boards out, and it's modular, so it's hidden at the bottom. But what we have spotted is we don't have this value of capacitor. It's a 1200 microfarad capacitor.
1200, yeah, 6.3 volts,
6.3
which is not one I've got in the drawers.
Otherwise, we would have tried maybe tacking one on there to see if we got any further. But we can actually see more capacitors of the type that we found that have leaked in the power supply. So we're going to get our whole a whole capacitor kit rather, and this board's going to come out and get redone. Yeah, that's about where we are.
Yeah, so I'm off to order some capacitors. There'll be a magic edit now where I'll reappear with the capacitors, but without Mark, because we're going to break for Christmas now. We're filming this just before Christmas. So Mark, thank you for your help today.
No problem at all.
Tell everyone where they can find you.
You can find me at markfixesstuff.co.uk or find me on YouTube at markfixesstuff. Subscribe to get your fix. I'm also on Twitter and Insta and all that rubbish as well, but I can't work it. I'm far too old.
So go and check Mark out, and yeah, let's edit to a place where I have some capacitors and we'll carry on this repair as if by magic.
Bing!
And as if by magic, all continuity is lost. My clothes have changed. The desoldering gun is out. We do have a table full of new capacitors ready to go, and we're going to get stuck in now. So let's see if we can carefully take all of these boards out to get to the board that we want right down there at the bottom, and if recapping that fixes the problem or if we need to dig deeper. Fingers crossed, let's get stuck in.
The challenge for me then was gaining access to the interface board right down at the bottom of the machine, and of course being able to put it all back together again. It did need some patience, but it wasn't necessary to remove everything to gain access to the board, thankfully. And before long I was able to double check all of the capacitor values, note them down, and start replacing them. Now you've seen plenty of caps already being replaced in this video, so I will keep it brief. The board was easy enough to work on, although I did need to snip some of the legs as the ground plane was more stubborn to extract caps on than the PSU board. There's also a couple of non-polarized caps on this board, and all of them are very clearly and correctly labelled. There are no caveats caused by mislabeling here like we found in the Amiga CD32. And the black port you can see vanishing into the chassis down at the bottom there, that's what the packs slide into.
Okay, everything's back together. I think we're ready for testing now. There's an awful lot going on in there. There's a lot of cables going between the various boards in there. So I think I've got it all connected up properly. I think I've allowed enough clearance for the trays. All we can do really now is hit the power button and see what happens. So cross your fingers. The second board's recapped. Let's see if it's made any difference. Now this is promising. As soon as I hit the power button there, the mechanism clunked. We didn't have that before, so there was movement where there wasn't movement before. Let's press the CD tray. See what happens. Oh, there's movement. Is it going to open? There it is. It's working. We've got our CD tray. Okay, let's try the Laserdisc tray. Oh, beautiful. Okay. We've certainly made progress. Something much better is happening with our Laserdisc player now. I think the next thing we need to do is plug a telly in and see if we can actually watch a movie on it. So for the DVD test, I've got the TV plugged in. Now remember, this is kicking out an NTSC signal into a PAL TV, and that's a good sign. We've already got stop in the top corner, which we didn't have before. So let's put a Laserdisc in and let's see what happens. I haven't actually cleaned the lens on the laser yet, so we may find we have problems with the dirty laser. We've got close. Now we've got some sounds that don't sound too good to me here. No, it's kicked the disc out again. So we've got more problems to look into, perhaps with the mechanical side of things. Maybe it's just catching on something, I don't know. Let's have another look.
So at this point, music CDs worked fine, but Laserdiscs just did this. You can hear the motor straining, the same motor that spins a music CD, so we know it works fine, just not with Laserdiscs. The cause, it seems, is that when the discs lock into place, there's too much pressure on the disc for it to spin. Pressure from above is applied onto the disc by this assembly, which is removed with 4 screws. This spring-loaded piece applies pressure to the top of the disc as it spins. So what we can do is ease the pressure on the disc and see if the motor manages better when it has a little less work to do. How can we do that? Well, quite simply by using some washers. I've got 4 of the rubber variety here, and I've just fitted one under each screw of the assembly to lift it by barely a couple of millimeters, and we'll see if that helps. And look at that, now our disc spins. Not only that, but our free Twister movie plays. You're seeing it in black and white, remember, because it's an NTSC signal on a PAL TV, so I'll have to get a converter in place for the next episode. The remote control works and all its functions are working perfectly. Audio is also great. Our LaserActive is, once again, fully active.
Well, I'm certainly really happy to have this working. It may not be the most powerful console of the period. In fact, given the Sega Megadrive status in 1993 and the PC Engine, it's fair to say that side of things was outdated. But it's certainly exotic. It's certainly nice to have in the collection. And I'm over the moon to have brought it back to life and to have it in the condition it is now. There's a lot more to do, of course. We've only recapped 2 out of the 4 main boards in there, and I'm not going to make you watch me recap another 100 or so capacitors that are in there. There's an awful lot to get through, as well as the game packs. The Sega Megadrive pack has the same reputation as the main device for having terrible capacitors, the same caps from the same period, from the same company. So we're going to take a look inside that in part 2. Our friend Gary has loaned us the PC Engine pack, so we'll get to take a look at that as well, and he's told me that he's having some audio problems with it, so we'll pop the lid open on that and see, no doubt, more problem capacitors in there. So we'll try and get that all fixed, but we won't dwell on capacitors for too long, because in part 2 I really want to show it in use. I want to show you things like the Mega LD Laserdisc based games, as well as regular Mega Drive games. There's no region locks on this, so we can play Mega Drive and PC Engine games from any region, and also we can explore things like the Sega Mega CD range. Maybe do some comparisons between the video quality of the Mega CD and the video quality of the equivalent Laserdisc games, because there are 1 or 2 that cross over. Not many, given the library is only 20 Laserdisc games, but we can do some comparisons. There's certainly a lot to cover. I hope you'll join me to continue to explore all that, and I'd like to say a very special thank you to Mark Fixes Stuff for joining us for the first part of this video. Do be sure to check him out, all the links are below in the description, and I hope you'll join me again soon for some more LaserActive goodness. Thanks for watching and take care.
If you enjoy my content and would like to toss a coin into the hat to support the cave, then check out patreon.com/retromancave and join the official cave dwellers you can see on the screen now. Thank you for your support.